Let's now look at a sphere. Unlike the cylinder or the cone, a sphere does not have any flat surface at all. A sphere, if you look at it, has just a curved surface, right? So there'll be no concept of flat area. The total surface area and the curved surface area for a sphere will be one and the same, right? Will be exactly the same because you see here the sphere has only a curved surface. It does not have any flat surface. Now, how can we visualize a sphere, right? Let's take a semicircle. Let's say this sphere has radius r. Let's take a semicircle with the same radius r. Now, rotate this semicircle about this axis. Take this axis and rotate the semicircle. As it starts rotating, what do you see is formed? A sphere, right? A sphere is formed. So when we rotated a rectangle, a cylinder was formed. When we rotated a triangle, a cone was formed. When you rotate a semicircle, a sphere is formed. Now, similar to the cone, if you look at these rings, right? The rings formed by each point on a semicircle have different radii, right? The largest one has a radius r, the smallest one has a radius 0, right? All of these rings have different radii. Now you'll also see that this surface is not linear, right? So we cannot use a simple average the way we did for the cone. Finding the average requires some advanced mathematics, calculus, right? Which you don't need to know right now. So since we are not able to find the average radius, let's try to use an experimental method instead. Let's take the same sphere and let's try to wrap the sphere with a thread, right? Take a thread and wrap the sphere around. What we are actually creating is the rings that we visualized earlier. We are now actually forming them using the thread. We have the entire sphere wrapped up. Now, let's see whether this same amount of thread can wrap a circle. Let's now take a circle with radius same as the radius of the sphere with same radius r. Let's take the same thread and start wrapping around the circle, right? We've wrapped around this circle. We still have a lot of thread left. Let's take one more circle with the same radius, right? Let's wrap this circle around. We still have thread left. Let's take one more circle. Put the thread around it. Once you finish wrapping the circle, you still have some more thread left. Let's take one more circle. Start putting the thread around this circle. When you finish it, you'll see that the entire thread is over. So what you see is that the thread required to wrap this one sphere is equal to the thread required to wrap these 4 flat circles, right? Now, all of these circles had the same radius r as the sphere, correct? So the area of each of these will be pi r squared. Area of each of these circles will be pi r squared, right? So the total area is 4 pi r squared, which means that the area of this sphere will be 4 pi r squared, right? So the area of the entire sphere will be 4 pi r squared. The entire surface is curved. So this 4 pi r squared is both your curved surface area as well as your total surface area. Instead of a sphere, if you now have hemispheres, if I split this into 2 parts, each of them will have a area of 2 pi r squared, right? Half of 4 pi r squared. So that's how you'll calculate the curved surface area as well as the total surface area of a sphere.
To keep learning with such engaging videos, download Byju's, the learning app today.